Hello, 20-2 students. So today we are carrying on with our basic factoring review as an intro to quadratics. So to start out with today, we want to look at determining a product if you're multiplying out, which we kind of looked at last time, and most students kind of remember how to do this. So two ways if you have a set of brackets with, whatever numbers or variables in them. There's kind of two main methods that are usually taught, so I'll just kind of go over them both in case you've learned one particular one or the other, and then we'll go from there. All right, I forgot to add in my box there. I didn't want to make you guys wait while I drew that out. So with the box method, basically what you're doing is you're setting up kind of this grid, kind of like an XOX grid, and you're setting up in the top two and the side two columns the variables from each bracket. So let's say we start out with this a minus b. It doesn't matter if you put it in the ones that go down or the ones that go across. I'll do it, let's see, what did I do for you guys in your notes? I did it across, so let's do it down this time. So we have a, and then just always remember to keep the value here together with the number or variable that comes right after it. So we're going to have negative b down here. Going across the top, we have positive a, and because we have plus b, we also have positive b. Now basically all you would do is fill in each box for what would happen if you multiplied the two columns that it's attached to together. So here we have a and a, so in this square we would put in a squared. In this one we have positive a and positive b, so we would have ab. In this column here, we would have a and negative b, so we're going to have negative ab. And in this column, we have negative b times by positive b, which is going to give us negative b squared. So now, basically, if I needed to determine my product, I would just say, okay, I have a squared plus ab, because this is positive, so that just tells me what I'm doing for the operation. Now I have negative ab, so minus ab. And then minus b squared. Then I can look at this and just see as my last step if I can simplify anything any further. So a squared, there's no other a squared to combine it with. There's two ab's, there's plus ab minus ab. So whenever you have two values that are the same but opposite in their signs, that means they cancel out to 0, like positive 1 and negative 1 would be 0. Same thing for plus ab and minus ab. So when we simplify this, and then there's just the negative b squared left over, which we can't do anything else with. So we end up with a squared minus b squared. Okay, would be our factored version of that. Now if you were doing FOIL, kind of the same thing, but you just don't draw out this difference, so a plus b. So these are the brackets that we have. FOIL, you're doing, first you do the first terms, you want to multiply them together. So that's a and a, which gives us a squared. Then you do the outside terms. So a is on the outside of the brackets and so is b. So we have a times positive b gives us plus ab. Then you do the inside brackets. So that's negative b times a, which is negative ab. And then you have the last values in the brackets. So that's negative b and positive b. So that gives us negative b squared. So we end up with this same setup here, and our factored version, or sorry, like our simplified version is just going to cancel these out and we'll have the same answer, a squared minus b squared. Okay, so that's just a reminder of the different kind of ways you can look at multiplying out your brackets. Now, looking at these specific ones is going to help us to think about where we're kind of going today in our factoring. So what are some characteristics you notice about this product in particular? Well, one of the first things, maybe what I would recommend you do is go through and write down some things you notice. If you don't get 4 things, that's okay, but if you do, great. So the first thing is we only have 2 terms, right? So that's what we call a binomial. So that's any expression that has 2 terms in it, because we see that word bi in there, which refers to 2. Then we have, what else do we notice? Like the first term is squared. And actually, I could have maybe made this 1 point, so I might cancel out 3. I'm going to say first term and last term are squared. Right, so all we have in here is 2 perfect squares. And then the other thing is we notice the sign in there is subtraction. And this is, believe it or not, this is going to help us figure out some stuff with factoring. So if you ever see any kind of a setup like this where you have just two terms, so it's a binomial, the first and the last terms are perfect squares, so they might not necessarily have the squared sign with them. But for example, in this case, we have two terms. X squared is, our first squared term. And 9 is technically a perfect square too, because that would be 3 squared, right? So if you have that and you have the subtraction sign in between them, that basically means that any kind of a setup like this, you can factor into two brackets that are going to be a single version of your variable, so in this case that's x, and then minus the square root of the second term, which is usually a number, so minus, in this case, 3 is the square root of 9. So we square root x squared and we square root the last term to get our values in our bracket. Then we're going to set up a second bracket. We're going to do the same thing. Square root of x squared is x, but instead of having a minus, we're going to have a plus in this one, and then again the square root of 9, which is 3. So we end up with x minus 3, x plus 3. Now for any binomial that's set up like this, where both the first and the last term are a perfect square, you're always going to get this for the brackets. And the reason for that is because when you have a negative and a positive value that are the same for your first and last values in the brackets, or sorry, for your last values in each bracket, I guess is the better way to say that, they're going to cancel out, right? Because you're always going to end up with plus that first term minus that other term. And that's always going to add to 0. So like if we FOIL this one out, we end up with x times x is x squared. X times 3 is plus 3x. Negative 3 times x is negative 3x. And negative 3 times positive 3 is negative 9. So we end up with plus 3x minus 3x cancels out, x squared minus 9. Okay, so let's look at some more examples just to kind of see this. So we have x squared minus 16. If we want to factor, and this is so nice and easy when you guys are factoring, guys, because basically as soon as you see those two terms, it's usually a dead giveaway that you want to look for whether or not they're perfect squares. So let's square root these. Square root of x squared is x. Square root of 16 is 4. So that means our brackets are going to be x plus 4, x minus 4. Okay, if you want, you can always try this one on your own. It's going to be a little bit more complex, but hopefully you'll be able to see that kind of same pattern there. So if you pause the video, give it a try yourself, and if you're back now, we have to square root the whole term. So we can square root 49 down to 7 and a squared down to a. And then we're going to subtract off the square root of 25, which is 5. So 7a minus 5, and then our second bracket, same thing, square root of 49 is 7, a squared is a. In this case, we want to have plus, and then the square root of 25 is 5. So there's our two brackets. Okay, so now, and again, I kind of messed up because I keep forgetting to mention this. It's like if you automatically see you have two perfect squares, that's probably fine. For this one, if we look at this, 18 is not a perfect square. Neither is 2. So we have a little bit of a problem. Even though we have these two terms, if these are not perfect squares, you need to, you should always be checking for your common factor, right? So for these ones, the common factor between 2 and 18 would just be 2. So we can divide 2 out of there. So move it outside the brackets. And 2x squared divided by 2 will leave us with x squared. And 18 divided by 2 is 9, so x squared minus 9. And now if we wanted to factor some more, we could look and see, we actually did this one, right? X squared minus 9 will give us x minus 3, x plus 3. So when we fully factor this one out, we end up with 2x plus 3, x minus 3. Okay, so there's our fully factored version. So don't forget that sometimes you do need to check for that greatest common factor that you can pull out first before you start trying to factor. Okay, now we also want to look at something called perfect square trinomials. So It's kind of similar to what we were just looking at, but in this case we have 3 terms instead of 2 when we're working with this. So let's try working through FOIL again to look at the product of x plus 5 squared. So if we have x plus 5, and you guys can of course try the box method as well. So remember, if you have x plus 5 squared, then you just have the bracket multiplied by itself twice, right? So if we FOIL it, first terms multiplied together gives us x squared. Outside terms, so x is on the outside and plus 5 is on the outside, so we have plus 5x. Inside terms, again, plus 5 times plus x gives us plus 5x. And our last terms are 5 times 5 would be plus 25. So now when we look at this product, if we want to simplify it a little bit further, x squared, there's no other squared term, so that stays the same. There's the 2x terms here in the middle, so plus 5 gives us plus 10x, and then the number term is just going to stay the same. So if we look at some characteristics about this product that we just determined, just going through like the 3 different terms. So if we look at our first term, we know that first term is just like a perfect square. Is perfect square. Actually, you guys, I'm not going to write these out for you. I'll finish this one. But so the first one is a perfect square. Our last one is also a perfect square, right? Square root of 25 is 5. And our middle term is, how is that related to this perfect square? How is 10 related to the square root of 25? Well, the square root of 25 is 5. The middle term is twice that value. Okay, and so you guys can check your filled in notes for this, but basically the middle term here is always going to be, if your first and last terms in a trinomial are perfect squares, the middle term is always going to be the square root of your last term doubled. Okay, so let's look at doing some factoring with these. So we have x squared plus 6x plus 9. So we look at this one and see that's a perfect square. And we look at this one and see that's a perfect square. So basically that means when we factor this, we know that our brackets are going to be the square root of 9, which is 3, and the square root of x, so x plus 3. And it's going to be x plus 3 times by x plus 3, just like we saw up here, right? So we can just say x plus 3 squared there. The only time that this is going to happen where both of your brackets are plus is if you have a middle term here that is like the square root of this doubled. So the square root of 9 is 3. If we double that, we get 6. So we know that this is an appropriate way to do this. If you guys don't want to really like try and remember this other way of doing things, you can just factor this by inspection the way that we've done in the previous lesson. So basically you would just say, what are 2 numbers that multiply to 9 and add to 3? And you would get positive 3, right? So then positive 3 and positive 3. So then you would know that your brackets were that. So just kind of depends. This can just be a little bit of a shortcut sometimes. Same thing for this one. X squared is a perfect square, of course, and so is 144. So that means our brackets are going to be x. Now, the only thing we have to be careful here is in this case we have minus 24x, but we still have a positive perfect square. So the only thing that can mean is that we have negative 12 times negative 12, which would give us positive 144, and negative 12 plus negative 12 would give us negative 24. So basically we're going to have x minus 12 squared. So same as this one, it's just that if this middle term is a negative 1, you know that you have to have a subtract sign in the bracket, but both of the brackets will still be the same, so you can still just write your squared sign. It's only if we don't have a middle term that the brackets are different in their signs. This one, 3 and 48, neither of those is a perfect square, so what do we always do then? Take out our greatest common factor. Greatest common factor between all 3 of these terms would be 3, right? That's our lowest number, and it fits into the other 2 terms. So let's divide 3 out. So we're going to have 3 on the outside. 3b squared divided by 3 leaves us with b squared, plus 24 divided by 3 is 8, and then we keep that b, and then 48 divided by 3 is plus 16. Now if we look at our term, always, once you take the greatest common factor out, always check and see if you can still simplify this by factoring it further. So b squared is a perfect square, and so is 16. So that means we're going to have 3 on the outside. The square root of b squared is b. We have positive values for both of these. Square root of 16 is 4, so we're going to have plus 4 squared is going to be our final answer for that one. Okay, so that is everything. You guys are all caught up on your factoring. Today was a pretty quick lesson, so if you've got the time, you can always move on to looking at our first lesson in quadratics. But if not, I will see you in the next lesson.